Hello guys, welcome back to my YouTube channel, and this is day 14 of June daily rate code challenge. So let's see today's question. Today's question is minimum absolute difference in BST. So let's understand the problem statement first. Given the root of a binary search tree BST, so BST means the values that will be coming in the left side of the root will be lesser, and the values that will be coming in the right side of root that will be higher. So in that BST, you need to return the minimum absolute difference between the value of any two different nodes. So you have this binary search tree, that is your BST. You need to find what is the minimum difference between any two nodes. So you are like seeing here, this is one between 1 and 2, the difference is 1. So you can check any two nodes, the difference cannot be lesser than 1. So in this case, the minimum difference will be 1. Like between 2 3, this is also 1. Then between 4 6, this is your 2. Then if you can check between 3 and 6, this is 3. So like every time higher we are higher greater value we are finding, so 1 will be the answer in this case. Let's see another case. So here we can check like between the difference between 0 and 1 is 1, between 48 and 49 is 1. Then here this is 47. Then here this is again higher difference, greater. So in this case also we cannot find a lesser value than 1. So 1 will be answer again in this case also. So let's see how we can actually address or approach this problem. So we have our BST here. So that like the time we are checking the difference, we can observe one thing. Like if I'm checking the difference between 1 and 4, so the difference is 3. Like if I'm checking like this is 3. If I'm checking 1 with 6, the difference is 5 more. Okay. If I'm checking the difference between 1 and 2, the difference is 1. Between 2 and 3, I'm checking the difference is 1. So what I can observe, like 1, 2, 3, 4, 6. What we are seeing, difference between these two is lesser, between these two is lesser, between these two is lesser, but the difference that we saw between 1 and 6 is higher. Why higher? Because this obvious thing, like you can observe, if the numbers like far away from each other, then the difference will be higher, obviously. Like if we are checking the difference between 1 and 6, the difference will be higher. If you are checking the difference between 1 and 2, the difference will be lesser. It is an obvious thing. So the intuition will be hit in my mind if I can actually put these number in such a way the numbers is sorted in nature. If I can actually sort these numbers, then I can check the minimum difference, because minimum difference will be the difference of a element with the closer elements. Definitely the difference, when the difference will be minimum, when we check the difference with its with its near elements, right? If I am checking the difference of from 2 to 6, this will make no sense, because the difference will be 4. This will be obviously higher. But if I can check the difference from 2 to its neighbor, its consecutive elements, so then the difference will be lesser. So the intuition is now hitting to us in the mind that if we can put the numbers together and we can just find the difference with near elements, and if we can actually check the difference with near elements, the difference will be definitely lesser, and we can actually track from for every element. We can do this and we can store, like this will be 1 in this case. So what approach, like this is your first approach, that extreme approach that we can see. Like in that, what we will do, we can actually traverse, like what will the time complexity, I'm writing side by side. Like we will traverse whole tree, so that will be order of n, because we are traversing all the nodes. Then we will store, we will actually store these nodes in one array, so that will take again order of n space complexity. And then like if we are traversing, so the order of h will be there, because for recursive is like space, because if you are doing with recursion, I will be doing with recursion, so order of h definitely. And then I need to sort the array, because when we will sort, then only the the numbers will be sorted in nature, the number will be near to each other. So for that I need to sort it. So this will be your TC and SC in extreme brute force approach. Can I optimize this? Yes, I can optimize this. Let's see how. we are sorting this with we are sorting it with we are sorting it that array or vector we are sorting. So can we eliminate this extra time for sorting? The answer is yes, we can eliminate. How? uh, this is BST. So if you do in-order traversal, so the result of in-order traversal is sorted in nature. So if you know in-order traversal, that is your left, then root, and then right. So if you go left, root, right, so from 4 you will go 2, from 2 you will go 1, and from 1 your game will start. Like 1, this is your inner traversal 1, then you will go to 2, then you will go to right, that is your 3, and you have since you have traversed your left subtree, you will go to root, so then root is 4, and from 4 you will go right, so that is your 6. So this is your inner traversal, and you are seeing this is already in sorted order, so you need not to sort it again. So this is how you can actually eliminate this extra time to sort. So this is your second approach, but you still need this array to store elements so that you can actually check the difference with closer elements, closer neighborhood elements, to track the minimum difference. So can you actually remove this extra space to store the elements? The answer is again yes, you can actually eliminate that also. So how you can do that? Let's see. Like for that you need to understand the in-order traversal clearly. So let's see in-order traversal with clear observation. So let me rub this so that you can understand it properly. Okay, so this is your BST, right? How you do another traversal? You go, like this is your route, you go to left, left, and if you are not finding anything in left and right, you will come to root, this is your 2, you will come here, and from 2 you will go right. Correct? This is how you do. So what you will be doing earlier, like you want, like if the number is 2, you are checking the minimum difference, you are checking the difference with the closer elements, with the neighborhood elements that are near to them, like 1 and 3. You are checking the difference between, from, like with them, like for 2 you are checking difference with 1, from 3 you are checking a difference with 2, from 4 you are checking a difference with 3. So you are checking one thing. We don't need every element, like to check minimum difference, you don't need every element at once. Like at a time you need only two elements, like the current element that we are on, and you need the previous element. You need previous element that is closer to check the minimum difference. So if you can actually track this previous element, like if you're on 2, if you can see who is my previous element, I say 1, just check the minimum difference. Yes sir, that is 1. And if you are on 3, you will say who is my previous, this is my previous, 2 is my previous, and you will see the difference is 1. So how you can like with the previous, like with the one variable, you can actually track the previous element, and with the help of previous element you can check the difference with the current element. So the third approach is this only, like you will do the in-order traversal as you are doing, but instead of storing the elements, you will, like when you are doing the traversal, at that time you will have one previous variable that will be indicating to your previously traversed element. You will just find the difference every time, you will be tracking the difference every time, and you will do your as usual another traversal, so you can find the minimum difference like this. So the approach and intuition was this for all these three approaches. I hope you have understood. Let's see the code for the optimized one. Like in the optimized one, this storage space will be eliminated, so you will be have only this order of h to traverse time complexity, sorry, space complexity, and time complexity will be order of n, like a simple inner traversal. Time complexity and space complexity will be in this case last. Optimized one, let's see the code. So you are initializing this answer variable to store the minimum difference, then you are just doing your in-order traversal. So in order traversal, what you do, general your traversing to left, traversing to right, and when you are on your root node, at that time you will be just tracking the minimum difference every time with current node to the previous node, and when you are done with that you are assigning this current node to this previous node, and every time you will be doing your business. Let's see once more. So if you are on 2, the previous element will be 1, so the minimum difference will be 1. When you are on 3, the previous element will be 2, so this will be 1. Like when you are on 4, the previous element will be 3, so the difference will be again 1. And when you are on 6, the previous element will be 4, so the difference will be 2. So actually you are checking the minimum difference, so the answer will be 1 in this case. So if you have understood, please like, comment, and you can subscribe the channel for more such content. Thank you.